Hello, my name is Chris Bianco, and I'm with the IBM Worldwide Technical Sales Team. I'd like to thank you for taking the time today to join us for this discussion of the virtual reality data layer, and in particular, how we can map IBM and open source solutions against the pain points and the use cases that often underlie these types of architectures. The use case that we'll be walking through today is designed intentionally to be modular and modifiable, such that as you are having a conversation with your clients about their use cases and the technologies that are part of their stack, we can modify and augment the type of story we build around this architecture specifically for that vertical and for that customer. So for example, if you're talking to a healthcare customer, what we've done around virtual reality headsets and Internet of Things devices can easily be transferred to the types of setups and connectivity that is found within a healthcare provider, particularly inside of a hospital. So we could substitute patient records in place of operational data, streaming sensors coming out of medical devices rather than gaming headsets, and so on. And so I encourage you, when you take this in front of a client, to have first the initial discussion, asking the questions as to what technology pieces are part of their stack today, what are you building with, and what do you aim to build with tomorrow? Because of the stringent requirements that these larger organizations and enterprise customers have around security, deployment patterns, access, and best practices, it's oftentimes difficult to modify and bring these open source solutions into a mission critical production application. What IBM and Compose have built around these open source tool sets and technologies is a platform that does give that layer of rigidity, governance, scalability, and flexibility and quality control that an enterprise customer ultimately requires in order to make that evolutionary step from test dev into full-on production utilizing open source technology. Now, in building a virtual reality data layer, I like to map specific use cases and pain points to data types and workflows. So for example, inside of a virtual reality headset, you imagine that there's a component for the games that will be played with that device and with those applications. There'll be a storefront that could be purchasing in-app unlocks, new items for your character, new content for your games. Thirdly, there'll be an analytical component into which a customer wants to do reporting. They have the need to do analytics against customer patterns of usage inside their application. And finally, for the headset itself, we can treat that device as a streaming Internet of Things type device, which has a continuous flow of data coming at us very quickly and in very large volumes. And for that reason, we'll want to supplement this architecture with some type of caching layer to allow us to ingest the data and then finally transform it before landing it elsewhere further down the stack. The key takeaway from this presentation, regardless of the customer type that you're speaking to or the industry vertical in which they find themselves, is the messaging that we can map best of breed open source technologies from Compose, as well as IBM enterprise ready services on SoftLayer and Bluemix against the type of pain points and business requirements that are driving their application stack and are part of the challenges that that customer foresees they'll be running into in the next years or months. Now, with that in mind, we can map our technology to specific domains or buckets according to data type, workflow, or use case. So for example, in the operational sense, we have a need for flexible schema, the ability to scale this out to a very large collection of users over a disparate number of devices that could be connected through cellular networks, running on the web, or some combination thereof. For that reason, we can oftentimes make recommendations around NoSQL databases as a service like Cloudant, MongoDB from open source, as well as ScyllaDB or Cassandra. For our transactional component, we can make recommendations around hardened relational database models, such as Postgres or MySQL or DashDB for transactions. Thirdly, we have our analytical suites, which will be driving not only our data scientists, but also our reports, our visualizations, and our deeper understanding of patterns of usage within our application. And these can be supported by technologies like DashDB for analytics, Elasticsearch from open source, and others. And finally, the fourth pillar, and really truly key and essential to this use case, is handling the data coming out of the connected device, the Internet of Things style sensors, which require both a combination of caching and transformation properties. So for example, we can utilize something like Redis to cache data, as well as Apache Spark to transform and cleanse the data prior to ingesting it to other data sources and other individuals further down the application stack. Now earlier we had promised that we would map and prescribe specific solutions from open source as well as from IBM catalog services against the specific challenges that this virtual reality headset layer would have to address. In service to the operational front end, we're going to recommend NoSQL Database as a Service IBM Cloudant to support the application running both on the mobile phone as well as on web-driven clusters. Secondly, for the transactional component, the underlying storefront that will be serving up purchases, handling microtransactions within the application layer, this will be supported by Postgres. Thirdly, for our analytical suite, we'll take advantage of the fact that we have a direct connector between IBM Cloudant and DashDB for analytics to handle and transform data coming out of the operational side and make it available for reporting. And finally, for the caching and streaming components, we'll be recommending a combination of open source Redis as well as analytics for Apache Spark from IBM Bluemix. And so in this chart, we are representing the division of responsibility between the operational layer, handled by IBM Cloudant in support of that mobile operational data front, and the transactional backend, which is going to be supporting our microtransactions and in-app purchases happening at the application layer, directly mapping to our Postgres database for that hardened relational model, which gives us the type of stringent ACID compliance and guaranteed levels of consistency that we would want underlying an application layer or transactional layer. To reach that next level of sophistication, to go further along the maturity curve towards a full application stack, is to integrate our operational front end with an analytical and reporting backend. And we can do this very simply with a built-in connector available directly out of the box between IBM Cloudant and IBM DashDB for analytics. This technology allows you to automatically and seamlessly scan through databases that you want to move out of JSON from Cloudant into a hardened analytical warehouse inside of DashDB, through which you can then provide deeper analytics, greater reporting, and visualizations of that data. Now think about the complexity of that type of action. The flexibility of JSON schema is precisely why we recommended Cloudant in place of our operational data store. It gives us the ability to adapt our schema on the fly without involvement from a DBA, but it also has the negative side effect from a relational point of view in that schema changes quite often within a database, and there's no homogeneous schema that maps to an entire database. What we've taken care of is that complexity of mapping and migrating NoSQL data into relational data precisely through that schema discovery process connector. Now within the transactional end, you'll have purchases being made within the storefront that might constitute some type of milestone or an achievement that you want to, as a sales or marketing organization, reward that customer for making that next level of spend. We can set up a monitoring service using something like RabbitMQ from Compose to monitor changes happening within our relational database inside of Postgres. And then when that milestone is reached, send an asynchronous notification to the marketing team on Slack to ensure that we are delivering the best possible experience and truly rewarding those customers that are making the next level of spend with our application layer. And finally, for the streaming data coming out of our Internet of Things device, out of that virtual reality headset, again, we have massive volumes of data coming at us very quickly. And so for that reason, we'll want to set up a caching layer in front of the rest of the stack. And that will be powered by Redis from Compose to first land the data and then prep it for transformation inside of analytics from Apache Spark. This service has a direct line connector directly to IBM Cloudant, which allows us to, again, take that transformed and cleansed data, serve it up either directly to the operational application layer or to the data scientists and analysts that are working within our analytical warehouse, again, taking advantage of that schema discovery process. Ultimately, what we managed to build here is a full stack architecture that incorporates the best of open source technologies from IBM Compose, as well as enterprise grade services directly from IBM Bluemix and on IBM SoftLayer. Once again, this has been Chris Bianco with the IBM Worldwide Technical Sales team, and I will see you next time.